Today I want to talk to you guys a little bit about this, the ImmersionRC RF Power Meter version 2. Now I've only just actually got this and I bought it for doing some tests on various pieces of equipment, and one of them was actually trying to test the output on digital VTXs such as the DJI ones or the HDZero ones. There have been some posts around Facebook and other places of people trying these on digital and not really getting much success, and I'll be honest, my own findings are very similar. What I'm finding is when I am trying to measure the digital signals, the levels are all over the place, no matter if you set it to peak or average. For instance, on channel 1, race channel 1 I should say, you're getting outputs that are somewhat representative, but it doesn't fully align. But the further you go up the frequency band and as you head up to race channel 8, the levels just drop down to a ridiculously low level and being as much as 100 milliwatts lower than the expected output. This is consistent no matter if you test it on the DJI Air unit or HDZero, which tells me the RF Power Meter version 2 is not liking those digital OFDM style carriers. Further to that, there's also some really odd behavior that when you measure it on the digital channel, it is sort of not representative, but if you measure it to the side of it, you get some completely random levels. So for instance, if you set the VTX on channel 5 and measure it on channel 3 or channel 8, the levels are showing 200 or 300 milliwatts higher than the maximum output of the unit. So something weird is going on with this power meter with regards to digital OFDM style video signals. For me, that then raised the question of, well, how does this perform in normal use? And I've been doing some tests with it on some Express LRS modules, and I'm just going to walk through some tests I'm going to do on these RF Designs radios, because these are very high quality pieces of kit, and I do think that the output from these will be a good representation of the outputs I would expect to find on normal style radios, whether it be traditional video VTXs or RC style control links. Now on these tests, I'm going to set this to, I've set them to one channel, so there's no frequency hopping, and I'll manually set the output that way, and I've also restricted it to antenna output number 1 to ensure that the outputs that I am getting are correct on the correct output as well. I will try and put in a little bit of footage talking about it as well, showing you it on the digital side. I've been doing a lot of tests on that and it's just a bit all over the place. But what we'll do first of all is just show you it on the RF Solution radios and just see what the numbers look like first of all. Okay, so to try and show this, we've got the RF Designs radio connected to the power meter. I've currently got this one set at 5 dBm. This one is the remote radio. There is a connected desktop radio over here, which is this one here. I've set this one to 1 dBm. That way it is going to be less than this one at all times. And we'll actually take a look at it on the spectrum analyzer as well to show you how the output actually looks as we change them too. But as you can see, set at 5 dBm, the reading on the radio meter is showing about, what, 4.6, 4.5, 4.7, something like that. I'm just going to place the box over the top there just to stop it moving around. If we hop over to the desktop view, you can see that we've got the RFD tools open, and this is the app that will allow us to configure the radio. And we then also got the spectrum view in the background. Currently, you're seeing it on the 3 views. So we've got the real-time IQ Power Spectrum view, which is the carrier of the telemetry link in the channel it's on. And I've actually fixed it onto a single channel right now to stop it moving around. So we've got a fixed channel and a fixed output. And then we've got the waterfall view, and then we've got the actual spectrum view here. If I just jump it over to change it to 8 channels and save those settings, that'll just show you the difference in how it actually behaves, and you'll then see the frequency hopping actually kick in. There you go. You can see that it's now frequency hopping between the 8 channels rather than the 1. However, what I'm going to do is manually set it to a single channel rather than have it jumping around. That way I'll have a more representative output on the power, because I'm only looking at a single channel rather than it jumping around on a number of channels and it trying to figure out which one it is. So again, we'll set it to a single channel, hit it on that, and then that way we should get our correct output get reflected on the meter as we start to have a look at how it works. So I've moved the screen around a little bit just so you can see the actual spectrum analysis a bit easier. We've got the single carrier now showing us down here. And what we'll then do as well is show you the display output in the bottom of the screen as we walk through the different outputs. So again, we're currently set on 5 dBm. This display might not change that much because this isn't actually an antenna. It's the unit itself measuring the power. So we're having to pick up the RF off the side of it, and we're not going to see the same output changes you would see with a normal antenna. But if we now move through the numbers, so we'll start at 10 dBm, save those settings, we'll give it a second to actually kick in, and we should see the display change. You haven't seen much change on the screen, however, it has increased, and at 10 dBm, it's showing 9.4, 9.3, so it is fairly accurate. If we then jump up to 15, hit save, wait for that to kick in, you can see it's jumped up to 14, 14.4. Again, is it the radio that's out slightly or is it the meter? I'm not sure. However, the reality is the numbers are very, very close. Go to 20, save those settings, and you will see the output on the screen change again. It's increased. And now we're showing 19.35. If we go to 25, save those settings, we're getting 24, 25, 24.6. So again, very, very close to the expected output we would find. And then if we go to 30, the maximum, and then if we wait for that, and we can see this does seem to come in a little bit lower. I've noticed on the 30 level, we're only getting 27, 28 dBm. Is that the radio or is that the meter under reading? I'm not exactly sure. Interesting is if we write it at 29, we don't really see any change in the output. It remains pretty much the same. If we go to 27, write the settings at that, see what that one actually does. You can see it has dropped down to 26 on that one. So we're getting roughly the expected output, but on the maximum output, we're hovering around the 28. But it is clear that the meter does seem fairly accurate, and this is consistent with the settings I'm seeing on the Express LRS modules as well. And actually at times on Express LRS modules, it's overreading at say 250 milliwatt. So I do think the meter in these situations is actually fairly accurate and representative of what we would expect to see. Just to quickly show you some more outputs on a radio, and I'm going to use an Express LRS module for this one. This is the Happy Model 2.4. I have been doing tests on other radios with other systems, and again, it's very representative, but I just wanted to show you the kind of differences we're getting too. So if we hop to the overhead on this one, I'm currently in the Lua script. I've currently got it set to 10 milliwatts output, and you can see it's showing 8.29, 8.36. If we then set it to 25, you can see that we're getting 23.46. If we set it to 50, 58, 59. So again, very, very close. If we do it to 100 milliwatts, we're getting 112. And if we go to the 250, we're actually getting over 300 on this module. I've got no reason to doubt that isn't correct, if I'm honest, based on the other tests I've done. So it does seem that some of these Happy model modules will output more. I've done tests on the Beta FPV one as well, and that one again, very similar. I'll hop onto that quickly now just to show you too, but it does seem that it's fair. It's a fair number. It's a fair representation. If we take it onto the average mode, you can see it's much, much lower, so that doesn't make sense. So we definitely want it onto the peaks. We've got the span at 80 milliseconds. We could change that to 160, but again, it really doesn't change the output any dramatic way. It just slows down the reading. If we go to 40, very similar again. We'll set it to 80 because that's the nice midpoint. But overall, it does seem fairly accurate on this one. Okay, now I've hopped over to the Beta FPV module. Now this one actually does 500 milliwatts output, and I've reset the Lua script. So if we now go down to TX power, and I don't know what I've actually got this set to as standard. So let's go back down to the beginning. I've gone down to 10 milliwatts. Let me just angle that so you guys can see it better. So on this module, 10 milliwatts is showing 1516. 25 is actually showing 35. Sorry, let me turn that back so you can see it. 35. 50 is showing roughly 50, 54. It's getting slightly more accurate as we go up. 100, 122, 250, 297, 300. Interesting, very similar to what we were seeing on the Happy model. And then 500, we're actually getting a bit under 448, so we're not quite hitting 500 on this module. I have found it does get a bit close to it as it first powers on, but yeah, it's slightly under reading. But again, I've got no reason to doubt the outputs that the meter's reflecting. I think the reality is what the modules are giving is what we're seeing on the display. The next thing we're going to show you this on is the HDZero digital system to show how it behaves in that scenario, and this is where the problems are coming up. Now, just to be clear, this is no different on DJI. It's nothing to do with HDZero. It is the way this power meter is reading on a digital signal. Now, here I have the digital VTX, which is the 200 milliwatt Whoop board. If I go to the overhead, just to show you, it's that one there. It's connected on the pigtail into the RF power meter, and I do have a fan here as well to blow cold air on it because these do get warm in use, and I want to make sure that the module doesn't enter any power saving when I'm trying to show you the results. I'm also just going to try and angle this all a little bit better to try and keep the fan from blowing into my microphone and putting noise on the screen. And then we've got the little board just to show you what the channels are as well as set the output. I'm going to show you it on max output because this is where the strange behavior seems to happen. And if I then also jump over to the desktop as well, I'll have it up here so you can see it on the spectrum display as well. That way you can actually see the carrier and the channels move as we do it. So if I power this up, we will check what channel I've actually got it on. So we've currently got it on channel number 1. So for that, we want to change the frequency on the spectrum just to get it to the right spot. So that is 5, 6, what is that off the top of my head? 5650 is what that will be. If we just change the level just to show you that a bit better as well, just to make the carrier stand out nicely. And what I'll do is I'll just shift it up a little bit more just so you guys can see it on the screen. There we go. You can see it there nicely. So if we then set the power meter as well, and I'm just going to zoom in just to make sure we are fully in, and we're going to set this to, what do we want? We want 5650 for this. I haven't got the channel list off the top of my head. So for channel 1, so we'll go to 5650. But this way, this will ensure that I'm getting it on the correct frequency. So as you can see, we are getting about 200 milliwatts of output on the display, which is what we would expect from this board. This board is the 200 milliwatts. It does vary slightly, but that is what we're getting. The settings on the power meter, I do have to peak, but I can set it to average. And if we do set it to average, again, we get very similar results, a bit lower on average than actually what we would expect. But as you can see, it is 167, but if we put it on peak, we are getting that 170, 180. It's been on a couple of seconds now, so it has dropped output because it is warming up. But when it is cold, we do get the 200 milliwatts output as we would expect. If we now change the channel up to channel 5, there we go. We've set the channel to channel number 5. We will then move up the spectrum until we find it. Here it comes. And we're looking for a center frequency on this one of 5800, which is nice and easy. So if we set the meter to 5800, back out, And this is where you start to see things go strange. You can see that the output is down to 135, 137 milliwatts. Much lower than we were reading before. And again, if we keep going up the channels and not dropping my fan, and if we go up to channel 8, wrong button, right to the top end, there we go, and we'll set the center frequency of that as 5900. Absolutely perfect. And come back. You can see again, the output is much lower than we would expect to find from the unit. Now, this does beg the question of, is it the unit that's wrong, as in the power meter, or is it the VTX? Having done a lot of tests with this on DJI as well as other HDZero VTXs, in my opinion, it is the way this meter is reading the output. And you can see it is dramatically lower. It's down now to 116 milliwatts. If I then set it back to channel 1, go back down to channel 1, and again, change it on the spectrum display, get it so you guys can see it nicely. We can see there that we're seeing the output of the display. However, I haven't changed the frequency of the meter. So the meter is still currently set to 5900, whereas we're actually on 5650 basically. But look at the power this display is showing. It is showing 260 and 250 milliwatts. If we then take it down to 5800, again, it's getting closer, but it's still overreading. And then if we go down to 5650, we're now down to 170, 180 milliwatt. And this is just really strange behavior. And I'll be honest, in all the tests that I've done, it is just not showing correctly. If I reduce the output on the VTX, so if I press and hold the button until we get the power 2, and then we'll set it back to power 1, you can actually see the output change on the spectrum display. So that is up to power 2, that is up to power 1. Just put the display there for you to see. You can see the massive difference in output, and we'll set that. And again, this same behavior happens. So we're showing 50 milliwatts there. But if we then change the frequency on this to 5800, it's now showing 70. If we go on the actual unit to channel 5 to actually go to 5800 and come back out, you can see it's about 40 milliwatts, so it is under reading again. Just to bring it in and show you, and center frequency is 5800 basically exactly. Again, it's showing 42 milliwatts. And if we then move it again up to this channel 8, we are seeing dramatically less. So we want to go to 5900 on that. Jump the analyzer up just to make sure we're correct. So center frequency 5916, which is absolutely perfect. We'll be fine. And now we're showing 32 dBms of output. And again, if we come off peak and go to average, it's less again. In theory, you would want to take an average on a carrier of this size. So if we go back down to number 1 and go to 5600, 5650, I mean, there we go. You can see it is closer to that 500. And again, set the spectrum back down. And then set the center carrier to 5667. That's absolutely fine. And again, if we go to that maximum power output and see how it behaves, go to number 2, 180. So it's close. But what is clear is this really odd behavior when we start moving it up the frequency. So if I go to 5800, look at that, it's now at 234 milliwatts of output. And even when we set it to 5900 on channel 8, come on the meter, it's vastly below 136 milliwatt compared to what it should be of like almost 200. And I've got no reason to believe the VTX is outputting any less power. For instance, if we look at where we are on the display, we're averaging a dBm of, where is it? Minus 41, 42, okay, on the display. And if we move it down to channel 1 and come down again, we're again minus 43, 44, a little bit higher, but nothing spectacular. And again, this isn't a proper way to measure power, but what you can see is we are not getting that mass changing output that you're seeing on this display from this meter. Okay, just before I wrap this video up, I just want to show you one last test. Now, I've got an analog VTX here this time, so we've got one of my random eSheens 48 channel 5G8 200 milliwatt mini. Okay, so remember, 200 milliwatt mini. If I hop over to the desktop view so you guys can see both, I've currently got the spectrum up as well, so you can see it being shown on the display here. We have our main video carrier in the center with the mirrored carriers either side. They're not important, don't worry about them. The main video carrier is this one here. If I just go to full screen, that's probably a better way for you guys to be able to see it here. And we've got a center frequency on this of 5600. So we can then set the meter to 5600 as well to make sure it's on the correct setting. And it's reading this as 459 milliwatts. So are they 200 milliwatts or are they 459? Interesting question. Now, what I really want to just understand is, am I seeing some of the drops as we move up the channel frequency as I was seeing earlier? And am I also still seeing that strange behavior that I was talking about? So what I'm going to do first of all is just move the meter onto 5850 as a channel. And you can now see, yes, we are seeing that strange behavior because that is now showing 700 milliwatts on the wrong frequency. So again, if we set it back down to 5.6, which we're on, we're seeing 467. If I change it from average to peak, we're seeing, yeah, it's virtually the same. There's no change there. So I'm really not sure what to make of this. I'm really not, based on when it's off, it's showing 600 milliwatts, but when we're on the right frequency for it, it's showing 457 on a 200 milliwatt output VTX. If we just change the settings further up the band, so if I just move it around, we'll try and get up to sort of 5.8, 5.9. I'm not sure the switch order on this thing, if I'm honest. Go there, let's... Okay, we're getting close. I want it higher than that. That's only 5... What's that? 5.76. No, we want to go up. Let's see if we can go further up the band. I think what we'll go is 5... Oh, we got 5.870. What's this one? We're getting close. 5.879. I'd like one of the others, just more bang on a number if I can. So it's not 5.9. Oh, this one's interesting. What's this one? Let's just have a look. That is 5.806. That's 5.800. So if we set it now to 5.800, again, 360 milliwatts. So it's still less than we were seeing before. But it is still much higher than I would expect from this 200 milliwatt, unless this is outputting that much, I should say. And then let's try and get one up at the 5.9 area. Let me just find a switch combination that gets us to that. If I wasn't being so lazy, I'd go and find... there we go. What we got? 5.865. So 5.850 would be that one. And again, 316 milliwatts. So what is interesting is as we're moving up the band, the numbers are coming down. We are seeing that reduced output. And then if we try and find one that gets us to 5.9. Oh, that's close. What's that one? 5.885. Nope. No. Okay, what's this one here? That is 5.925, bit high. I'd like to get it somewhere between it. Oh, there we go. I think we've got it. 5.904. Perfect. We'll go with that. So we'll just adjust that so you guys can just see it there. 5.904, so 5.900. And again now, that is 280 milliwatts output compared to that nearly 400 or over 400 on the lower level. So we're seeing very similar behavior in that around the 5,600, it appears to be about right at 5 gigs. Although this module is putting out more, but that isn't to say that this isn't putting out more. But what we're definitely seeing is we move up the band, those frequencies, and move further towards the top end, the power output comes down across all of the modules, and on the other stuff, it's less reflective of the true power we would be expecting. Okay, so where do we stand with this power meter from ImmersionRC? Well, I'll be honest, I have as many questions now as I had at the start of this. With regards to measuring output on RC modules, for instance, at 2.4 gigs, I think it looks right. While some of the numbers aren't what we would expect, I think probably some of these modules are outputting more than they've said. The numbers are close. I wouldn't say they're 100% accurate, but ImmersionRC do say the device is 0.5 dB accurate. I think at 2.4 gigs, everything looks good. At 5 gigs, things get interesting because I'm not happy with any of the readings I'm getting at the moment. On analog, as you've seen on a 200 milliwatt VTX, and unfortunately this is the only one I've got I can actually use at the moment, it's showing 400 milliwatts. It's an eMachine or eSheen 48 channel 200 milliwatt. Perhaps it is outputting 400. Perhaps that is correct. But again, we're seeing that trend where as you move up the frequency band, the reading is dropping. Is that the VTX? Is that the meter? On digital, on both HDZero and DJI at 5,600, I'm seeing what I would expect, but very odd readings as I move up the band. As we move again towards 5,900, Channel 8 race band, things are not looking as I would expect them to be. And for instance, on the HDZero 500 milliwatt VTX, I'm getting numbers as low as 80 milliwatts at 5,900. And I don't believe for 1 minute that is correct from the VTX. I am sure the VTX is outputting more than that. At the lower end, I'm seeing, again, reflective numbers of where I would expect. As you've seen on the Whoop board today, we're getting about 200 milliwatts, 180 to 200 milliwatts at channel 1. But as we moved up to that channel 8, we were going back down to 120, 134 milliwatts. So things are not clear. What I would say is this. It's hard to say these devices are accurate. What it is, though, is a way of measuring power output relative to another device. And so at the moment, you would pick your baseline device, for instance, and use that to measure if something is more or less. I'm going to try and reach out to ImmersionRC and understand more on what we're seeing and why we're seeing, especially that strange increase in output as you move off the channel band. So you leave your VTX on channel 1 and you go to channel 8 and measure, and it's showing 400 watts on a 200 watt output. That just doesn't make a lot of sense. As I said at the start, it raises more questions than it answers right now, and I can't really say I would accept any reading you see from anywhere on this as a definitive answer for anything right now, because we simply do not know. I'd like to try and test it against some proper RF equipment. My spectrum analyzer isn't ideal for measuring RF the way it's set up. However, I'd like to try and measure it on another power meter and see what kind of results we're getting. here and now, I think the conclusion is that use it as a way of testing between devices, but don't accept the actual number as 100% regardless where you see it. Now, that's it from me on this one. I would like to thank everyone for spending some time with me on this video. I hope you found it interesting. Let me know what you think about this in the comment section. Have you got any thoughts on what we're seeing? Because it's all very, very odd. I'd also like to say a massive thank you to Aronia for lending us the Spectrum V6. That is the spectrum analyzer you are seeing me use in this video. They have very kindly lent us this very high-end piece of equipment that allows us to do amazing things, and there's lots of content coming on that in the near future as well. Finally, I'd just like to say, if you like what you see, please do hit the subscribe button. Don't forget to hit the little bell. Also, don't forget to check out our Patreon as well as buy me a coffee if you'd like to support the channel further. And come and check out my Discord server as well if you want to see more of stuff like this that I do on a daily basis. Anyway, that's it from me. Stay safe. I will speak to you soon.